This is problem 27 from chapter 14 of the textbook Stats Modeling the World. Okay, here we're rolling a die, a fair die, 3 times. So we're being asked a bunch of questions. Okay, so the first one is, what's the probability that you roll all 6s? So the probability of all 6s. So, you could kind of do a tree, but I don't know if we need to do a tree here, because what's the probability? It's like an and. The probability of getting a 6 is just 1 out of 6, and not getting a 6 is 5 out of 6. So you roll it once, but they're independent events, right? The second roll is going to have the same probability, 5 out of 6, 6, and so on. So it's just going to be 1 6 times 1 6 times 1 6. Okay, so I get approximately 0.005. Okay, now you roll all odd numbers. So it's going to be 3. So the probability of all odd numbers. So let's see, if we roll the first time, well, you get 1, 2, 3, 4, 5, 6. These are all the outcomes. So an odd, odd, and odd. So it's going to be 3 out of 6. So they're all going to be odd. So I think it's going to be 3 out of 6 times 3 out of 6 times 3 out of 6. Okay, why? Well, think of it this way. The probability of an odd is going to be the probability of getting a 1 or a 3 or a 5. And that's the probability of a 1 plus the probability of a 2 plus the probability of a 5. Okay, so that's 1 6 plus 1 6 plus 1 6, so that's 3 6. Okay, so just rolling once, the probability of getting an odd is 3 over 6, and we're going to do it 3 times. So I get 0.125. That's my answer. Okay, moving on. None of your rolls gets a number divisible by 3. Okay, so first, that's going to be, let's go back to the outcomes. 1, 2, 3, 4, 5, and 6. So this is divisible by 3, and that's divisible by 3. 6 and 3 are divisible by 3. So it looks like there's going to be 4 out of 6 that are not divisible by 3. Okay, so I'm not going to need a tree. I'm just going to say probability of none divisible by 3 is 4 over 6 times 4 over 6 times 4 over 6. And that comes out to be 0.296 approximately. On some of these, I can't remember where I rounded, but on some of these I rounded. So I'm going to say approximately on some of these. Okay, you roll at least 1 5. Alright, let's see. Let's see if a tree helps me. I get a 5 or not, a 5, and then a 5, not a 5, a 5, not a 5, a 5, not a 5, 5, not a 5, 5, not a 5, 5, not a 5. Okay, so first roll I get a 5 or not a 5. Second roll, third roll. So now at least one. So here I've got 3 5s, 2, 5 and 5, 2, 1, 2, 1, 1, 0. So I want to add up all of these. I want the probability of getting a 3, this 3, the 2s, and the 1s. So that's a lot of work, multiplying this all out. So why don't I just multiply this one and subtract from 1, because the sum of these probabilities should add to 1. So let's see, you get at least 1 5, so that would be 1 out of 6. So this is going to be 5 out of 6. So in other words, it's going to be probability of at least 1 5 is going to be equal to 1 minus the probability of all not 5. Okay, so that's 1 minus 5 out of 6 times 5 out of 6 times 5 out of 6. So 5 out of 6 times 5 out of 6 times 5 out of 6. Okay, and that comes to approximately 0.421. Okay, so first time I did this video, I was a little confused by this last question, so I'm going to take this out because I was trying to decide what it meant. So I finally figured it out by doing a tree. So the number you roll are not all 5s. Okay, so that's hard for me to process. So I'm going to have to think through it. So I'm going to go back through again and do a tree, just because I don't like the other one that I drew. It was kind of messy. Okay, so I'm going to get a 5, 5, and a 5, not 5, not 5, not 5, not 5, not, and not. Okay, so the number you roll are not all 5s. So this is all 5s right here. So it must be all of these, right? Because somewhere they're not all 5s. There's some 5s, 2s, and so on, but not all 5s. So that would be the probability of not all 5s. Well, instead of adding all these up, computing and adding these, I'm just going to do this one and subtract it from 1. So it's 1 minus the probability of all 5s. So that's going to be 1 minus, so the probability of a 5 is 1 out of 6, and 1 out of 6, and 1 out of 6. So 1 out of 6 times 1 out of 6 times 1 out of 6. That's how I approach that one, and I get 0.995. Okay, so I hope that helps. Good luck.